All right, welcome to part 2. In this section, we're going to talk about making some parts inside SolidWorks. So here, what we want to do is finish this sketch up and make it into a solid geometry. And our primary means of making the solid geometry are our Extrude boss base as well as our Revolve boss base. So in this one, I've already have an Extrude set up from the previous example. I do want to define all of the parameters on here, and so you never want to go into a finalized geometry until you really have everything inside the part defined fully. I have this 2 on here, which is not allowing me to define that height appropriately. So I'm going to take that off for a second. So this has a height of 12 and a width . And then I'm actually going to delete this arc off the top. Oops, sorry, wrong button. I just want to merge those 2 together. So I'm just going to control click the 2 points and then click on merge. There we go. And I'll go ahead and extrude this to the length. So right here, this is typically what you want to start off with for your first extrude, is a simple mid-plane extrude. If you want to have a revolve geometry, then in our sketch, what we really should have had is a center line and then the geometry that we wanted to revolve about. So just to give you guys an example of what that looks like, if I wanted to add a kind of torus shape embossed onto this part, I could just draw the circle relative to the center line here, and then I can come into my revolve features, and I can revolve that around. Obviously, that's going to be a bit too big for the part if you want to come off the edges there, but just to give you an idea of how that works. Keep in mind, you do have the same set of options as far as up to next, surface, offset from surface, and midplane. So if you only want this to go for a certain section length, say 90 degrees, then you can do stuff like that very easily in the revolve options. I'm going to discard that sketch and go back to my original one. Again, I said before that if you wanted to add fillets to a part, very easy to do that inside the feature. And one of the nice things about this is if you have, let's do big, multiple edges that need to be rounded the same way, which in a lot of parts you do, it'll have something where it says you have a typical fillet radius, or you have fillets on, a lot of the different surfaces or on a specific face. You can apply those fillets using the edge or the face. And when you use the face, it's going to use all of the edges that are attached to that face. So I can very quickly kind of fillet the entire part by selecting the faces rather than selecting all of the edges. And that's going to save me time. And actually, I don't even need to get all of the faces if I just get all the faces on the perimeter of the object in one direction, and that goes very quickly. You'll also note that it ignores duplicate selections. So if I have extra things selected, it doesn't give me an error. It just says, okay, well, that edge is already there. I don't need to do it again. I'm just going to do that one once for each of the edges that are selected. Tangent propagation, usually you want to have on, although not always. I almost always want to have the full preview on. It goes a little bit slower, but not slow enough to make a difference. And chances are, if it doesn't show up in the preview, it's not going to work inside your part to begin with. And if that happens, then you think about other ways of adding the round to that feature. Can you do that inside the sketch as opposed to inside the feature geometry? Or is there some reason that that's not allowing you to add that where you want it? And you got to go back and kind of debug that a little bit. So in this part, let's say I want to have rounds on just my corners. I'm going to unselect these faces, and I'm doing this by clicking on the face from the model, the listing here, the feature listing, and then hitting the delete key on the keyboard. I can also do it by toggling just by selecting them again. Just knowing some different ways of making those selections is very helpful. For each of your features, you're going to have this feature selection box. The blue one is the one that's active. And if you don't know what that's for, a lot of times you can hover over that box and it'll give you a little tooltip that tells you what it's expecting inside that box. So if you are asked to use a feature or you think you need to use a feature that you're not familiar with, try that first. If that doesn't work, come into your search bar, search the help for the feature, and it'll give you some more detail on how to use that feature. Again, using that help tool, using the search option to search for different commands, totally legit. If you don't know where to find something, search for it. Very easy to use. So I'm going to round each of these corners. Let's go ahead and use an inch. And that gives us some basic geometry. Now, if we want to add more features to this part, there's lots of different options that we can do. And you think about adding more geometry. Typically, the geometry you're adding to a part is a function of the geometry that's there in the beginning. And I want to show you guys a few tools to very quickly add different features to a part. The first thing is just doing extrude cuts and extrude revolves. Those are your most basic options. They're going to work exactly like the boss extrude and the revolve boss base, because they are the same tool. They just subtract instead of add. But most of the time when I'm sketching on a part to remove something, I'm going to sketch on one of the faces of the part rather than the original planes. Now, if what you're sketching is going to go all the way through the part, then yeah, use the base planes, because then this can be less dependent on changes later on. But again, most of the time when you're adding those additional features, it's because you want them to have some relation to the existing part geometry, and therefore you need to do that. So one of my favorite tools when I sketch is to use the convert entities and the offset entities tool. So if I want to make this into kind of like an open box, I'm going to use the offset entities to start off with, specify the wall that I want there. And then if I need to add additional features onto that, like say I don't want this to cover the entire box, I just want it to be a portion of it, then I would go and maybe wall off a section of that and then trim out the excess. And this gives me a nice way of making that section inside the part. Now, on more advanced users, you say, well, maybe you could use a shell tool to get that. Yeah, you can. But use the tools that you're most comfortable with as you're working through the parts, so that way you get the geometry that you want without having to worry about accidentally messing things up. So with that convert entities or with that offset entities, I can get very quick geometry, or very complex geometry very quickly just by using that face selection. It's going to use the whole perimeter of whatever I selected. Then I can extrude that out. A lot of times when you're given the thickness, you're not given the depth of the extrude right from where you're at. You're given the depth of the extrude up to a certain point. Keep in mind, you have all these options for how you want to extrude that part. So, an offset maybe makes sense for a starting point if you don't want that cut to start on the plane that you were actually sketching on. Maybe you want it to be inside the part a certain amount. And again, you can just insert that in, and you can make a hollow region inside a part very easily using that offset without having to create a reference geometry. The next thing you might want to do here is you might want to have it go to an offset from a surface, or using these other options to get a specific depth of cut without being given additional geometry or without having to do any kind of math. I find offset to surface being one of the most commonly used kind of features inside CSWA, where they want you to have the cut go up to a certain distance from the back of a part. So in this case, this cut is going to 1 inch from the back wall, which is very common. And again, you can kind of see what that looks like. The other thing that I really suggest you guys use is the section view. This is a great way of kind of inspecting your part to make sure you have it set up the way that you want it to. And when you're given a section view inside of a drawing where you have that cross hatching, you can use this to kind of verify that you are getting the geometry that you were expecting or that you want. So if you click on that section view, the defaults are going to be your front, top, and right planes. And you can see how that cuts the part in half. And you see this lighter surface is showing me where that cut is being kind of going out. And I can use these options to pull this out or rotate it to get it to face however I want. I can also just toggle between the different planes, or manually type in different offsets to get those different cuts. After you hit the accept button, it's going to keep that section the way it is. And then you can toggle it on and off again, just by clicking on the button once more. So very helpful in seeing some of that interior geometry. The other thing you probably see a lot of is use of the hole wizard. A little bit less common in CSWA, but you may have some hole callouts because they do want to check to see if you know that tool. Really, you got to watch for and make sure you're paying attention to the type of hole. So is it a counter bore? Is it a countersink? Is it just a blind hole? Those blind holes are probably the most common because you can use them with just circles, and so it's less likely to trip somebody up. But you have those options. Just make sure that you're positioning the hole before you start trying to type in all the values. I find that positioning the hole first is a lot easier than trying to get everything typed in and then figuring out where it's going to be, especially if you're not sure exactly, say from a design standpoint, you're working on these parts and you don't know exactly what size to use. Positioning the hole, picking on the surface, and then selecting where you want to put the hole can help you decide kind of what size of hole to use on a more kind of generic design standpoint. So if I have this selected first, I can go through and I can say, okay, well, I know I'm in inches, so I want to use an ASI inch size, and maybe I want to use, a standard drill or a standard screw type. I can specify that screw type inside my options here, and then I can just specify how deep do I want that hole to be later on. And if you don't know how deep you want it to be, then most of the time you're going to use a through hole. Now, this would be a really, really small screw in a big part, probably not something you want to use. And again, you can see that just by looking at it. So that's something that's very helpful. So maybe I want to go to maybe 3/8 inch and use a slightly larger piece there. Don't be afraid to have things be underdefined as you're working. Or sorry, not underdefined as you're working, but don't be afraid to start off with very simple shapes and not try and do everything all at once. The biggest mistake that I see when people are making parts is they try and do all of the geometry at the same time rather than breaking it up into smaller chunks. Very easy to add complexity to a simple model. It's hard to fix a complex model when something breaks. So if I draw everything out on the first sketch and get all that geometry in there, I've spent a bunch of time, and then if something goes wrong, I have to spend a bunch of time to fix it because all of my features are very complex. If your features are simple, then they're typically very easy to fix. To that effect, the other tool I really recommend that you all use is the cut extrudes using a single line. And to do this, all you need to do is make sure that line crosses the face of the part. So say I want to make a recess here to be able to get to that screw more easily. I can come in and I can sketch on this face. Then as long as my sketch crosses the face from one end to the other, it will allow me to do that cut extrude with just that one line. I don't have to spend time converting the edges of the rest of the part. Again, I want this to be fully defined, so I'm just going to define the sizes here. Let's say make it 3 by 3, and we'll make that radius 1 inch. Again, so just 3 entities crossing that sketch. I'm just using my middle mouse button to rotate that a little bit. When I go and extrude cut this, all I have to do is tell it which side of this do I want to cut. Cut the inside or the outside, and it's going to go ahead and cut it the way that I had defined on there. The other thing that's important, that say you want to define these distances relative to my exterior features here, not a problem. All I need to do is go into my sketch and change my view type so I can see those interior faces. And so I typically use the hidden line view to do that. Although you can also just rotate your part to the other side and sketch from the other view where you can see those features, even though your sketch isn't on that side of the part. So I think the hidden line's nice. It allows me to stay on the same side, but if you don't like that view because it just gets confusing, or maybe it's very complicated because you have a lot of features kind of stacked on top of each other, use those different view options to make it easier for you to see what you're doing inside the part. And then you can see, we can go through and we can define the offsets relative to these interior features as opposed to using those exterior edges, if that's what I'm given inside the problem statement. You always want to try and use as much as you can the dimensions that you're given in the actual part itself when you're going through and you're making parts inside of the CSWA exam. Because if you have to do math or conversions or different features, it's going to take you longer generally, and it's also going to make you more prone to error. Where if you did that mental math wrong, again, even if you made the part right using all the correct features, you still are not going to have the right geometry. Another thing I want to mention is the use of drafts. Now, drafts won't work with these single line cuts, but whenever you're using a simple boss extrude, or a boss cut, or even a revolve. Well, actually, I'm not sure you can do it with revolve. So whenever you're doing boss extrudes and boss cuts, you can add drafts to the actual extrude itself, which on the CSWA, most of the time, if you're adding a draft, that's the only type of draft you're going to be adding. It's one of those ones where you're basing it off of the original sketch itself. So in this case, I'm going to change my view type so we can see the solid lines a little bit better here. When I add this draft to the part, we can see that there's now an angle coming in from all these surfaces. And that's a very easy tool to add if you're doing it in that context. Now, keep in mind that on this one, since I used one of those edges, it is using that kind of larger edge when I did it. So adding drafts after the fact can create issues further down the line. Whereas most of the time, if you add them very early on, it's going to work out better for you. If you all enjoyed that part, we're going to do one more part on assemblies, and then we're going to transition to doing some work for CSWA practice.